Okay, in this video, we are exploring question number 4. Which quantitative data has a positive relationship with the starting salary? Let's go back to the original question, why we have this data set. People are really curious if they are going to certain kind of MBA program, will that consider a good investment? That means, will that leading to higher starting salaries? So therefore, for the question number 4, it being asked very naturally is that is a certain factor actually has some kind of positive relationship with my starting salary. That means that the value increase will increase my starting salary. So to answer that question, we need to think about which numeric statistic we learn to help us understanding the relationship between two quantitative variables. So in the class, we learned two different kind of statistics. One is covariance, the other is called a correlation coefficient. And so in the real world, we prefer to use correlation coefficient because it will tell us not only the direction of the relationship, but also the strength. For the covariance, we only can base on the sign, positive or negative, to identify whether we have positive relationship or negative relationship. We cannot base on the covariance to understand the strength. So therefore, since correlation coefficient has more information, so we prefer to use correlation coefficient in the real world. But of course, sometimes people do choose to use a covariance. So therefore, we still try to practice on how to calculate covariance and also how to calculate correlation coefficient. Okay, so if you look at the quantitative data we have 1, 2, 3, 4, 5, 6. We need to look at all 6 variables, each one of them, what kind of relationship they have with our starting salary. Okay, first, let's look at our first relationship, which is full-time enrollment versus salary. Okay, and then let's first look at our covariance. And we consider it as sample covariance. The reason is that in Asian, we definitely have more than 25 MBA programs. So here we only sample part of them. And the second, we will look at the correlation coefficient. Okay. So to calculate the covariance in Excel, you just need to remember a formula called a covariance. You literally spell the whole word, covariance. And then as you type in this word, you have two options. One is called the P, the other one is called the S. What's the difference? So in the class, we're talking about full covariance because the formula we saw on the PowerPoint. So the population, the sample, you are calculate using very different formulas because the denominators. So therefore, you get two different answers. So therefore, for the Excel, we do design the formula depends on you're dealing with population or sample. So if you're dealing with the population, you use the P. So the P stands for population, and the S stands for the sample. So like I said, in this case, we're dealing with the sample data. Therefore, we use the S, and then parentheses. Now it's allow you to select 2 arrays. So the 2 array means a 2 column of data. So the 2 column data are separated by the comma. So therefore, let's just select our first array, which is we're looking at the relationship between the full-time enrollment versus salary. So the first array will be the full-time enrollment, comma, and then the second array will be the starting salary. Okay, and then close the parentheses. So for covariance and correlation coefficient, it doesn't matter, you select the starting salary first and then for full-time enrollment. So the order of the array doesn't matter. So the key is please do not include the labels. So for the variance, for this formula, it only can recognize numbers. So if you end up including label, so the calculation will not happen, it just gives you error. So therefore, remember, in order to use these formulas, similar as the one called average, you only select data, okay? Then you can click push enter. So it's negative. So that means the full-time enrollment versus the salary have a negative relationship. Basically, the more student enroll, the fewer salary student starting salary. Kind of makes sense because maybe because the student, the university are not selective enough to getting the most best candidate who are able to find the best job. Or another reason is because the student who didn't get enough attention from the faculty, and so that they are not able to actually learn a lot and then to demonstrate to the employer and to find a better job. So This makes sense, but we don't know from the statistics how strong these two variables are correlated. So therefore, we need to use the correlation coefficient. So to calculate the correlation coefficient, the formula we are using called CORREL. So basically, is the first 6 letter of your correlation. Okay, let's type CORREL. So for this formula, we don't have two different formula for sample and population, because in our PowerPoint, when I demonstrating the formula, it showed that the mathematical calculation for sample and population are exactly the same. So there is no difference. Therefore, on Excel, we only have one formula. There is no .s or .p options. So it's just called correlation. So after you type that, and then we are selecting the full-time enrollment, comma, and then we select the starting salary. Okay, exactly same way as we selected for covariance, and then we push enter. Now we got negative, so negative 0.38. So still negative relationship. However, this relationship is weak. So how do we know it's weak? So if the absolute value of this coefficient is between 0.5 to 0, and we consider as weak. If the absolute value is between 0.5 and 1, and that would be considered as strong. As you see this number, the absolute value of the correlation coefficient is 0.38. So it is close to 0, and it's between 0.5 and 0. So we consider this as a weak negative relationship. Okay, weak negative relationship. Now I will do the same calculation for the rest of the 5 variables. And so you can do on your end. So you can see at the end, are you getting the same answer as I got? So the next one is the student per faculty versus salary. And then we are doing the same thing, covariance. Okay. CO here, covariance dot S. Student per faculty, salary. Okay, I got a positive relationship. And then correlation, student per faculty, and then salary. Okay, it is very, very weak positive relationship. Not surprising. I'm not really, actually I was initially thinking it's a negative relationship, but it seems like from what we see here is positive, but the relationship is very weak. It's almost saying the student per faculty is not really affecting the starting salaries, had no correlation with the starting salaries. Okay, so the next one is local tuition versus salary. Ideally, it will be positive, right? That means you pay more tuition, you're looking for more salaries. Let's see if we're getting a positive relationship or whether they are strong. Okay. Covariance, the S. Okay, and then let's see local tuition, starting salary. Oh, positive relationship. Let's see if they are strong. Local tuition, starting salary. Very good. It's a strong positive relationship. That means if you go to school, charge you high, and your starting salary also tend to be high. That make you feel good because you do end up paying more money, and you hopefully can get more out of it. So that's good. How about our foreign tuitions? So our covariance dot S. So our foreign tuition, starting salary, still positive. How about the strength? Foreign tuition, starting salary. Okay, still strong, but not as strong as our local tuitions. Still positive, strong relationship correlation is 0.66, larger than 0.5, right? So, and it's a positive, so it's a strong positive relationship. But like I said, it's not as strong as local tuitions. Now we move on to the age. Okay, what is the covariance? What is correlation coefficient? Okay, the age, starting salary. Okay, positive relationship. So the older you are, the older the student are, the higher starting salary they will make. How about the strength? Okay, so it's positive correlation, right? It's a strong because it's larger than 0.5. So it's between the absolute value for correlation coefficient is larger, is between 0.5 and 1, so we consider it strong. But if you look at this correlation coefficient, compare that with the local tuition versus salary. So our salary is have much stronger correlation with the local tuition versus the age. Okay, so the last one is the relationship between percentage of foreign student and salary. Okay, so let's see what's the covariance. So covariance, and I will select the percentage of foreign, then starting salary. Okay, it's positive. How about the strength? Foreign, starting salary. Okay, so basically the percentage of foreign student does have the positive relationship with starting salary, but if you look at correlation coefficient, the absolute value is between 0 and 0.5, so therefore it's considered as a weak positive relationship. Now, after you do all the relationship analysis, you will notice that among all 6 factors, and then the local tuition, foreign tuition, age, percentage of foreigner and the foreign student, and also the student per faculty all has a positive relationship with the starting salary. However, the local tuition has the strongest positive relationship with the starting salary. Okay, so this is the analysis to answer question number 4.